Okay, so how do we then solve those things if we have a base and it is raised to an exponent? How do we solve it? What are some things that we know about exponents? From back in our exponent rule, we learned that any number that is raised to a 0 is equal to 1. We also learned that any number raised to the power of 1 equals that number. And these are the two main things, the rules that we're going to use whenever we're working out finding your coordinate points for those graphs. That any number raised to the power of 0 equals 1, and any number raised to the power of 1 always equals that number of itself. A couple of the other things that we need to remember about exponents is that if I have an exponent raised to a power and it is multiplied times the same base raised to a different power, when my bases are the same, I am adding the exponents. Okay? And we're going to work these backwards, but this is why it is working. We also knew that when I have an exponent raised to a power divided by, a base raised to a power and another base raised to a different power, when my bases are the same, I subtract my exponent. So in this case, it is xa minus b. Okay? So these were our basic exponent rules that we learned for our variables. I'm going to leave this up. Okay, so back to, I now have a base. I have it raised to a power. Well, when I had x raised to a 2, I just took the square root of it, right? Because the square root index with the power cancels out, I get underneath. Or if I have an x to a 3, then I would need to take a cube root of it. So that was wonderful when we had numbers raised to, or had variables raised to an exponent. Now we have this base raised to a variable, okay? The way that we solve that, whereas before we used a square root, the way that we solve it now is called a logarithm. So this is where you're getting the log, where it pulls in. It can also be written ln. These are equivalent. It just depends on, typically this is referred to as natural log, which uses a base of e, but you will see log, you will see ln whenever they're looking at logarithms, okay? So a logarithm is the way that we rewrite our equation so that we can solve it. And what it tells us, in the same way here, I'm going to call this our base. I'm going to call this our exponent. And then that would give us some answer. Okay, so we would write the log of 2 raised to some power. I'm just going to call our answer A. Gives us an answer. And the way I like to think about this, because this 2 is actually dropped down a little bit, is that I always do a circle. So 2, which is dropped down, raised to the x equals A. If I were to take this out, take the log out, and to rewrite it as an actual equation, log 2 of A equals x would be 2 to the x equals A. So let's look at a couple of ones. I thought I had some examples from your, let me see. Okay, so if I have 2 to the x equals 8, okay, and I wanted to rewrite that as a log, I would do log 2 is my base, so it goes down here in my base spot. 8 is my answer, so it goes in the answer spot. And x is my exponent. So log 2 of 8 equals x. This is the way we've gone back and forth. So if I were to rewrite this, I would do my circle around. So 2 to the x equals 8. In this case, we know that x would be equal to 3. So we would be able to replace that. So if I have log 3 to the 9 equals x, I'm going to start at my base. I'm going to circle around. 3 to the x equals 9. Well, that's something that I can answer because I know that 3 squared equals 9. So x has to be equal to 2 in that case. Okay, I'm going to do one more that way. So log 4 to the 16 equals x. I would start at my 4. I'm going to circle around. 4 to the x equals 16. So x must be equal to 2. Okay. So then, if we have, in the other case, if I started with 3x equals 27, to solve that, or to rewrite it, I would say log 3, because my base always goes first. The answer is 27 equals x. So I'm going to go backwards. I'm going to put my base down, put my answer down, and it equals my exponent. Okay, and then you can always, once you're in the log form, you can always just use your circle to double check. That would be 3 to the x equals 27. Okay, that's what I had. That means that I'm right in this direction. Okay.